Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Time for another segment on building this new ST70 kit. If there's any parts or tools that are specific to this segment or the build in general, check the description below. Can't guarantee that these links are going to be good months from now, so if they're dead when you go to look, you may have to go hunt these parts somewhere else. Don't email me. I'm not going to hunt them up for you. So that said, let's get busy building. Okay, so we're going to wire up the power cord today. And what the instructions and what they give you, they tell you to put this little grommet in this hole and then use this non-polarized plug, put it through, tie a knot, and then run one of these over to the fuse and one over to the switch. Okay, we're not doing that. That's like 1950s electrical wiring, and I would never sell an amplifier that was wired that way. The problem is the chassis is floating and it's not connected to ground. So if you have a failure of an output transformer or anything, it won't blow the fuse and the chassis could end up being hot. And I just don't feel comfortable wiring up an amp that way. So we're going to be using this 3-prong plug with a 3-wire cord. And then to install it in the chassis, I got some of these gland nut strain relief on Amazon. And one of the things I had to do to get it to fit in the hole in the chassis is, let me zoom in here, I had to cut a couple of flats on the sides of it and make it that shape, like that. Hopefully you can see there what I did. The hole in the chassis is also that shape, and I did have to file it vertically just a little bit to get the threads to clear, but now this sits in here like that. Can't turn, fits in there nice and tight. So what we're going to be doing is we stripped off enough of this for these wires to reach over here to this ground lug and to wherever else we need to go. And then you put it, first you put this nut on, like that, and then you slide this through like this, and then you slide that through until it just pokes out the other side. And then as you tighten up this other nut, it crimps down on the outside of it. And we'll tighten up the rest of the way once we get it installed in the amp. These 2 wires are going to come over this direction. That one's going to go that way. And we'll go over how we're wiring this up once we stick this in. And then we get washer and the nut. Slide that into the chassis. Put the washer on. Tighten the nut up. Tighten that up. And then we'll tighten up the nut on the inside. And this is all plastic thread, so you don't want to get too crazy with it, but I'm going to go ahead and get it pretty snug, like that. And then you can see that's not going anywhere. So next, as you can see, I haven't put the fuse holder in yet because we need to solder this ground wire up. So it's going to come in here Just like that. I'm going to come in and solder this guy in place first. Just like that. Get my fan going here. Okay, so now we have the chassis grounded to the earth ground of the house, which to me is just a must-do for a tube amp. But there's a lot of people that don't do that, or will argue that it causes ground loops and that sort of thing, and possibly it would if we were using the chassis for the signal ground, but we're not going to be doing that. We're going to be wiring this thing as a star ground product, and so we're not going to have that concern. So the next thing we do is we install this fuse holder and snug it up. Again, this is kind of a plastic piece. You don't want to tighten it up so tight that it rips it in two, but you do want it pretty snug. And then we bend that guy out like that. So the next thing we're going to do is we're going to attach this black wire to this center. And the reason you do that is so when you're taking the fuse out, this outside leg isn't hot if it's still plugged in. And you're least likely to shock yourself messing with the fuse in case you forget. There we go. And we're going to come in here and solder this guy on. Just like that. Okay, now you think alternating current, it doesn't matter which wire is which. Well, because we have a earth grounded circuit, this is the hot. You want the hot lead going to the fuse, then you want the other side of the fuse going from here over to the switch, and then from the switch to the transformer lead, and then from the transformer lead back to the neutral to return back to the house. So we're going to pull these guys across the top of the amp like this, and we know one of them is going to go to the switch like that, and we don't want a lot of slop in this, so that looks good there. And then the other one is going to be tied to this neutral wire. Actually, I think, and this is going to be kind of silly, but I think if I wind it this way, it'll lay out better. There we go. See, that's going to lay out better. So we're going to connect that. I'm going to go ahead and strip this back, connect it to our switch. We want just enough to go through the switch. Actually, I'm going to put it in this top one. Let's go ahead and solder this one onto the switch terminal. That. we've got some extra wire here from our transformer that we can use to go across from the fuse to the switch. The reason we're doing this, so if somehow the switch fails and that this hot lead somehow shorts the ground, it'll blow the fuse. And without this ground connection, if this switch did short the ground, it wouldn't blow the fuse and the chassis would just sit there hot. Which is another reason that I don't think that two-prong connector with a floating chassis is a good idea for a tube amp. Basically built that way, it's what's called a Class 0 product as far as installation protection, and you might be able to sell these in the US, but there's a lot of countries in the world that just do not allow Class 0 products to be sold. And then Class 1 is what we're building, which is single insulated, which means that the chassis surrounds all of the voltage and it's connected to the earth ground. And then the other one is double insulated, which means that there's a lot of different protections inside the product that ensure that the high voltage inside can never end up on the outside of the chassis. And I'll actually put a link in the description. There was quite a long thread on AudioKarma about this recently, and you will see that I am a huge proponent of wiring these things as Class 1 and not building tube amps as a Class 0 or a uninsulated product. But I'm pretty sure when this amp was originally designed, they didn't even have grounded outlets. So that wasn't even an option. So the other thing I'm going to do is, there's two different ways you can like insulate this or cover this up. One of them is to put some heat shrink tubing on it. The other is to use this stuff, liquid electrical tape. And that's what we're going to be doing. Once we get all of this wired up, I'm going to be painting over the switch and all the exposed metal on this fuse with that liquid electrical tape. So the next thing we want to do, and we're going to twist those two together. That's perfectly fine. And then the next thing I want to do is tie these two together. So we are going to splice these two. Definitely put some heat shrink tubing over this splice. So then the next step is to put some liquid electrical tape over these connections on the fuse, on this part up here at the body. As you can see, I'm putting a second coat on right now. It's kind of funny to me, UL and all these electrical codes are really anal about having any exposed 120 volt AC insulated like this or with heat shrink tubing, but they don't seem to care. There's 700 volts AC over here. But anyway, so I got 2 coats on this stuff. I put 2 coats on this splice here, and then we're going to put the heat shrink tubing over the top of that after it dries. So let me give this about 5 minutes to dry, and we'll come back and finish wiring this up. Okay, so we got the heat shrink tubing slid down over here over this joint. Here's a little trick that I use, is the this little part of the iron here that's not tinned, just run it up against the heat shrink tubing and it'll shrink it right up. Just like that. There we go. So we got that joint done. And we're going to continue our wrap here around this. Maybe go the other direction. I think the other direction will work better. Like this, and then come down to the other side of the switch. Like that. It looks fancy, huh? And strip this off. Pull that guy up. And come in here and solder this to the other side of the switch. Like that. And there we go. Because we're real anal, we could twist those two together, but I'm not going to worry about that. And then I'll come in here, a little more of this liquid electrical tape. Those two. And all done. With that little drip off. And there we go. So now we're ready to power this thing up. And we've got the fuse and the fuse holder. And we'll come in with our voltmeter and check for heater voltages, our 5 volts, and then our high voltage AC here. And make sure that we don't blow a fuse. Okay, we're going to come in here and check our voltages. We got some little clip leads here. And there's various kinds of these. Some of them look like little alligator clips, which are actually easier to deal with than these little things that I'm fighting with. But these are what I've got sitting here handy. So we're going to put them across the high voltage first. And we have the amp unplugged. So there's no way there can be any voltage on any of this stuff. And there's our voltmeter. Now we're going to plug in the amp. And boom, 765 volts or 760 volts. That'll come down a little bit once we put a load on it, which is true with all these voltages. These are unloaded voltages. So we got our high voltage AC, and fuse didn't blow, so that's good. There's no capacitors in the system, so there's no stored voltage. As soon as you turn the amp off, the voltage goes away. So turn it off, unplugged it. Now we're going to move our leads over here and check our 5 volt pins and see if we got our 5 volts AC for the rectifier tube filament. And then plug the amp in. And 5.75 volts, 7 volts. Yeah, that's great. And like, again, these are unloaded voltages. Once you put a load on them, they're going to come down. So again, we turn off the amp, unplug it. And I know you see the little thing at the start of my videos. The high voltage inside these amps is no joke, guys. You do not want to like try to skip steps and whatever and end up electrocuting yourself. Nobody's going to be happy if you do that. So, come in here. And let's see if we got 6.3 volts over here. 6.85. That'll work. For unloaded AC, that works for me. Unplug it. We've got one final check over here. I'm going to come check the 6.3 volts on the other rail, on the other side of the amp. It's a little unusual. They have two different 6.3 volt rails. The amps I build usually just have one, but that's okay. So we're going to come over here and check this one, and we're checking at the end of the daisy chain, so we know if we've got it here that we've got it there. And so one last test. There we go. We got AC voltage on those heaters. So, got it unplugged again. Disconnect our leads. So now we've got all of our AC wiring done. The next thing I'm going to do is deal with these plate and screen wires from the output transformers and connect those up to the tubes. They're going to be connected up here in the front of the amp. These are going to go like that. And then once we get those connected, we can start working on the DC wiring, which will put our capacitor in. We'll run the DC from pin 8 of this tube over to the capacitor, connect the choke, get our B plus all going here, and then finally we can put our board in. So we're zipping right along, made some progress. I like being able to test as we go along, so we know that if the next step, when we go to test stuff, if it blows a fuse, we know all the AC wiring is right. And we'll go over one last time how I wired up the AC. The black wire, which is the hot, comes over here, connects to that terminal of the fuse, and then the side of the fuse comes over here to the switch. Then one side of the transformer hooks to the other side of the switch, and then the other side of the transformer comes to the neutral wire that goes back to the wall outlet. That way, if the switch shorts out or goes to ground, it's after the fuse, and it'll blow the fuse. And then down here, we've got our earth safety ground connected to the chassis, which will ensure that the chassis can never get hot. And if something does fail, like the choke shorts out to the chassis, or the switch shorts out to the chassis, it'll blow the fuse. And there's no way that the outside of the amplifier can ever get hot. So, anyway, I think this is a great place to wrap up this segment. So that wraps up another segment of this ST70 new kit build. Want to add that this is not sponsored by Tubes for Hi-Fi, nor do I have any affiliation with them. This kit was drop shipped to me by a viewer that commissioned me to build this for them. Now, I don't normally do kit builds professionally, so yeah, I may or may not be willing to do it in the future. We'll see what that's all about, but for now, we're just doing this one for the channel and for some fun. I want to thank all you Patreon supporters and folks that make donations at my website. If you find this information useful, please consider joining my Patreon or making a donation at my website. It really helps fund future projects and keeps this channel going. I also want to thank you regular viewers and especially you subscribers. If you haven't subscribed yet, please click the subscribe button. It's not a big deal to do. It doesn't cost you anything, and it helps the channel grow and other people see my fun content. So that's going to wrap this up. Until the next segment, have a nice day.